This is the final video project for Team Dodge This, consisting of myself, Annie Thornburg, Cody Dawson, Ricardo Carbonell, and Ryan Thomas. Today we'll be going over the design evaluations, our design testing, the final competition, performance and results, and a thank you to our professors.
The evaluation matrix allows us to compare each design's performance against customer requirements of our product, listed on the left of the matrix. If a robot cannot accomplish the ultimate goal of scoring points and receiving a high score, then the design will not succeed. With this comparison, we are able to identify which design will be most successful in accomplishing our goal.
Going into each individual design, our first design includes drawer slides to move to the rubber object and extend it to the center of the arena. It uses a stiff arm to move the rubber object from the area and uses extendable arms that are pushed by actuators to extend to the tennis balls. In order to retrieve the doll, the arm first senses the barrier with a long arm switch and then launches a hook to pull the doll in the area. Finally, ping pong balls are placed in the designated area by sensing with an IR sensor and places the balls by pushing them from the box attached to the drawer slides. This design excels in that it's really easy to set up and is fully autonomous, but has some components like IR sensors and the hook that impacts the object's highest score and its consistent performance. Overall, the design achieved a relative total of 19%, which is not bad, but it is not the highest.
Design 2 uses drawer slides to extend to the rubber bone as well as get to the center, and it pushes the rubber bone forward. It sensors the barrier for the doll using IR sensor, and it also uses an roller switch to sense where the ping pong balls need to be placed. And for the tennis balls, it has extendable arms which extend out and pull the tennis balls back into the home zone. Design 2 did well with ease of repair and autonomy. However, it didn't do well with consistent performance, which would lead to it also not doing well with high score.
Our third design includes extendable arms that are pushed by actuators in order to extend to the tennis balls and remove the rubber object from the area. In order to retrieve the doll, the drawer slides are used to reach the center of the arena. The machine first senses the barrier with a long arm switch that is attached to a primary arm. It then uses a secondary arm to launch a net that captures the doll, and then a DC motor reels the arm back into the arena. Finally, ping pong balls are placed in the designated area by sensing with an IR sensor and places the balls by reaching inside the area and dropping them from a box attached to the drawer slides. This design excels in that it's really easy to set up, is stable, and is fully autonomous. It performs somewhat consistent, which in turn yields a medium score. This is because the dropping mechanism is not as reliable, and the extendable arms will not always be able to get the rubber object out of the area. Overall, the design achieved a relative total of 21%, which is not bad, but as well is not the highest. Our fourth design includes extendable arms that are pushed by actuators in order to extend to the tennis ball. It uses a rolling cart attached to an arm to remove the rubber object from the area and extend to the center of the arena. In order to retrieve the doll, an arm with an IR sensor is attached to the cart and deploys a hook that pulls the doll in the area. Finally, ping pong balls are placed in the designated area by sensing with a long arm switch and places the balls by launching them through a tube into the designated area. Just by looking at the evaluation matrix, you can tell that this is not the best design. Although it should always extend to the tennis balls perfectly, the rubber object removing and ping pong launching mechanism have a lot of variables that will not make it as reliable as the other designs. Overall, the design achieved a relative total of 18%, the lowest score. Our fifth design is the design we're using for the final competition. It includes extendable arms that are pushed by actuators in order to extend to the tennis balls. It uses drawer slides to extend to the center of the arena and deposit ping pong balls by sensing the barrier with a roller switch and then rolling the balls inside. In order to retrieve the doll, the machine first senses the barrier with an IR sensor that is attached to a primary arm. It then uses a secondary arm to reach and corral the doll. A DC motor is then used to tighten a string that grabs the doll and retracts the whole machine back into its original position. On its way back, a flexible arm brings the rubber object with it out of the arena. Finally, this design is extremely easy to set up and is the one that has the most consistent performing mechanisms. This is why we received a score of 4 for high score. The mechanism also should withstand many trials, awarding a score of 4 for stable and durable. Overall, this design got a relative total of 22%, the highest of them all.
Take me away from home. Show me all the places I've never known. And we'll chase the night, erase all of these broken dreams and flight. And we'll
Yeah. There went 200 hours of our life.
Goodbye.